All right, assignment 5.3, question number 1. This assignment has to do with inverses and how it connects also to calculus. So first is some pre-cal. Can you find the inverse of f at x? That's what g at x is. So let's start. X and y, they switch. And then I'm going to solve for y. So I'm going to add 1, and I'm going to cube root. There it is. And the symbol for that is this for inverse. Often that doesn't get used as much. Notice how it got defined as g at x. It gets very confusing with notation and calculus. When this is not an exponent, it's not a derivative, it's a symbol for inverse, and it can get confusing with other symbols that we use in calculus. But anyway, there is the inverse. Graph them. So x cubed subtract 1, there's the point of inflection. Plus 1 means it's been shifted 1 to the left, and there's the cube root and what it looks like. And then you can see that they reflect over this line, which is y equals x. That's the definition of inverse. Find the derivative of both. So the derivative is 3x squared. The derivative, this is the inverse here. So we're going to write that calculus friendly to the 1/3. So this would be 1/3 x plus 1, subtract 1 to the exponent. And then there's no hook there. So there that is. And then it says find, and this is where the calculus connection is, what's the derivative at 1? So if I look here, 1, 0, 1, and then 1 take away 1 is 0. 1, 0 is a point on f at x. So the derivative at 1, that's what this is 3. And then the derivative, if I do the inverse of this, that point as an inverse is 0, 1. And then the derivative of g at that number, 0, would be reciprocal. Well, let's see if that's true. So we plug this into the derivative 0. 1 to any exponent is 1. And so you're left with 1/3. And that's the calculus connection to inverses. That the derivatives are reciprocals. E, reciprocals. All right, number 2. So the point 1, 2 is obviously on there, and what does it say? So we're going to repeat what we did in number 1. All right, so what's the inverse of this? Solve for y. We're going to add 1 and divide everything by 3. That's the inverse. We're going to graph them. So negative 1 and then up 3. 1, 2, 3. And over 1. There it is. Here, the inverse of that, I'm not going to do mx plus b. So if I take a point, this point here, which is 0, negative 1, then negative 1, 0 is on there. This point is at 1 and 2, so 2, 1 is on there. Again, they reflect over the line y equals x. This is f at x. This is the inverse. What is next? Derivatives. So the derivative here for f at x is 3. See how you do, if you did negative 1 in that, it becomes like a pain to identify the derivative because you have a negative 1 in this, whatever. So the derivative here is the slope, which is 1/3. And then no matter what I plug in, the derivative is always 3, the derivative is always 1/3. So the derivative at 1 is 3. The derivative of the inverse at 0 is 1/3. No, sorry, this one's 0 because it's 0. So which one? What are we doing here? Oh, 1, 2, sorry. So there's 1. The derivative here at 2, and notice what's the relationship? They are reciprocals. Number 3. So first find the inverse. I just want you to recognize that it needs to be a one-to-one function, which is fine, but this down here is not one-to-one. So we need a domain restriction, so this is only when x is greater than or equal to 0. So when I graph this, so I start at -1 and draw my square root. Here, I'm going to start down here at -1, but only do half of it. So not the other half, or else they're not reciprocal. So I have to do this domain restriction. So if you like, here, the range is y is greater than or equal to 0. That range becomes the domain of the inverse. Next, we're going to write it calculus friendly, and we're going to find the derivative. And then for the inverse, the derivative is 2x. And then what point? 3, 2. So the derivative at 3 plus here, I'll show 3 plus 1. 3 plus 1 is 4. The square root of 4 is 2, and that negative means reciprocal. So if I put it together, that's 1/4. Here, if I take the derivative at the y coordinate, which is 2, notice, plug in 2, and what do you notice here? They are reciprocals. That's the big idea of the lesson. Number 4. Let f and g be inverses, and it gives you a bunch of information. I'm going to do it right here. You need to write it down, but I'm going to do it right here in my book because I don't want to rewrite that down. Find each of the following if possible. What's the derivative at -1 for g? So if that's the case, then that's the y coordinate, that what I'm looking for. And I don't know for number 4. Oh, I have it right here. And maybe it is good to draw like a chart kind of thing. Let's do that to organize it. Maybe this is helpful. Let's do it this way. So in the question it says -1, 0 is a point on f, which means 0, -1 is on g. The derivative of -1 is 4/3, which means the derivative of 0 is the reciprocal of that. See how that connection happens? Let's do it again. So we have a point 0, 1. So on the inverse it's 1, 0. The derivative at 0 is 1/5. That means the derivative at 1 is the reciprocal. One more point, 1, 3. So we have 3, 1. So the derivative at 1 is 4/3. No, is 2. And that means the derivative at 3 is the reciprocal. So now let's answer it. That's actually way more helpful. So the derivative at -1, did I already do that work? So the derivative at -1, did I write down the first one wrong? Oh, here, this should have said not possible. That's what I thought. I don't have information on this. So when I look here, this is what I get information on. That's why I kind of hesitated and then did the chart. I'm thinking, I think the answer, I don't have the information to get that one. For B, the derivative at 0, I got that. For C, the derivative at 2, I don't got that. Oops, I skipped one. The derivative at 1, that one I do have. The derivative at 2, I do not have on that chart. And then the derivative at 3, that's 1/2. All right, so this chart is helpful, right? Because then it starts getting any flippity-floppy in your head, right? To be able to organize it and see it and then answer it is more powerful. Number 5. So I'm going to chart this. So we have f of x, g at x is the inverse, let's call it. And then the derivative and the derivative. I think that'd be helpful. So we have a point which is at 2, 3. The inverse of that is 3, 2. The derivative at 2 is 4. So the derivative at 3 would be the reciprocal, which is 1/4. And there's your answer. Number 6. If 1, 2 is a point on f at x, then the inverse at 2, what's the derivative of that? So first of all, what's the derivative of f at x? 3x squared plus 2. The derivative at 1 is 5. So therefore the derivative at 2 is the reciprocal of that, which is 1/5. Number 7. F at x equals x cubed, and then I'm going to write this calculus friendly right away. 4x to the negative 1, and it says the inverse at 6. Let's see if we can follow this. So, all right, let's chart it out. So we have f at x, we have the inverse. Let's start there, and then the derivative and the derivative. Okay, so for f at x, we don't have any number. This is the only number I have, which is 6. So the x coordinate for the inverse is 6. That means the y coordinate for f at x must be 6, right? They're inverses. So I'm going to go back to this function, and I'm going to make it equal to 6, and then I'm going to solve for x. So I'm going to write it back algebra friendly to solve this. What would you do to solve this? I don't want to go the wrong way. Oh, it says guess and check or use a calculator. If I was going to guess this, the number I would guess is x equals 2. So 2 cubed is 8. 4 divided by 2 is 2, and it works. It's 8 divided, take away 2, which is 6. You could also use your calculator to do it. Jeez Louise. So that means the missing number there is 2. So what's the derivative of this? That's 3x squared plus 4x negative 2. Plug in 2. Into here, so that's 12. 2 squared is 4, but you do the reciprocal, so the 4's cross out, and that leaves you with 13. So that means what we're looking for, which is this up here, is the reciprocal of that. So the answer is 1/13. There's your end answer. Not too bad, right? If we organize it and practice it, we can do this. All right, number 8. So f and g are inverses. Again, I'm going to do a chart because I think that's helpful. There you are. So we know a point 2,5. So the inverse of that is 5/2. The derivative at 2 is negative 2/3. So the derivative at 5 is negative 3/2. Number 9, I'm just going to follow this chart as I go down. So for number 9, the point is 1, 2. So the inverse is 2, 1. The derivative at 1, well, first I need to here on the side, I'm going to take the derivative of f, which is 5x to the 4th plus 6x squared. I'm going to plug 2 into that, and what answer do I get? or for number 9. Sorry, I'm going to plug 1 into that, I'm sorry. That makes it easier. That's 11. And that means the derivative at 2 would be the reciprocal, which is 1 over 11. Number 10. E. I like E. So first we need a point. So they give you the x coordinate for the inverse, which is 1. So that means the y coordinate here is 1, which means I'm going to make this equal to 1 to find the x value. And so that answer is 2. Because 2 take away 2 is 0, e to the 0 is 1. And so I fill that in. The derivative at 2, so the derivative of e to the x minus 2 is the same. E to the x minus 2, there's no hook there. So when I plug in 2 take away 2, we get that answer. So that means the reciprocal is going to give you the same answer. Number 11. You have a function, and it says find the largest interval in terms of it having an inverse function. So that would mean the largest interval in terms of only increasing or only decreasing. So I'm going to take the derivative, make it equal to 0 and solve it. So that's like 1.5. So when I put that down, 1.5, I know it's concave up. So I know it decreases and then it increases. And so the largest interval that contains 1 would be this interval. So that would be from negative infinity to 1.5. That's what we're looking for. That's what contains 1. So 1 is here. So from negative infinity to 1.5, it's a 1-to-1 function and has an inverse. Number 12. So I'm going to take the derivative equal to 0. I'm going to add 3x squared, divide by 3. And then when I square root, I get positive and negative 2. The power term is negative x cubed. That means it goes up to the right and down to the, so this is going to decrease, increase, decrease. So it goes down and then up and then down. But I know the end behavior, that helps me here, and then in the middle, which is the one that contains 3. That's this over here, right? So from 2 to infinity contains 3, and that's the interval where it's 1-to-1. What number are we at? 13. In number 13, take the derivative equal to 0. I'm going to divide everything by 3, and I'll factor it. It's negative 1 and negative 1, so there's only one answer. And then when I look at the derivative, both, no matter what number I plug in, the answer is always positive, except for here. So that means the entire function is 1-to-1. All right, 14. Oh, some good practice here. Because it's been a while taking derivatives. So can you find the second derivative here? So the first derivative, and I'm going to make that calculus friendly, obviously. So that would be negative x to the negative 2, and then the second derivative would be 5 plus 2. So be careful of your signs as you do it. Oops, I forgot an exponent there. So that makes it 20x 3. Let's do it right. Number 15. The derivative of 6 to the x minus 3 to the 4 This is the derivative of an exponential, ultimately, but ultimately it's the power rule. So it's 4 in front, 6 to the 2x minus 3, and then the hook. So the derivative of 6 to the 2x is 6 to the 2x. It needs a ln 6 and the hook, which is 2. And you could multiply 4 and 2 together to make 8. Number 16. This is called the quotient rule. What is the quotient rule? It's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. You could also write that as 2x. Number 17. So the first derivative would be 5, 2t minus 1, and then there's a hook of 2. Because I'm taking the derivative again, I'm going to simplify it. So 2 times 5 is 10. And then we're going to take the derivative again, and 4 times 10. And then we have a hook of 2. You could also write that as 80, but that's a good answer. Number 18. So I'm going to do some integration now. Whenever I see absolute value, I definitely think of the graph first in terms of what's happening. Now, if I understand this with absolute value, and it's going to be around, so 3/4 to the x to the 5th, the vertex of this is at 0. And so absolute value, think of like, even, who cares about the 3/4? If I just think of x to the 5th, this is what it looks like as a sketch. If I do absolute value, both go up. So if I integrate from 0 to 2 only, and then double the answer, that's exactly what I'm looking for. So I'm going to double the answer. I'm going to integrate from 0 to 2, and go from there. How do I integrate that? Add 1 to the exponent, divide, and then plug in 2. When I plug in 0, the answer is 0, so there's your answer. You could simplify that if your heart wants to simplify that. Go from there. All right, I'm going to see what's happening here. All right.